Hi, in today's video we're gonna go over sorry, that's my brother. I don't know what was he doing. But okay, today's we're gonna go over the nervous system. And the reason I tried to get my brother to do it was because I already recorded this, but then it corrupted it apparently. So then I have to re-record it, and then there's a whole nother thing. And then dinosaurs invaded my house. But anyways, okay, so we're gonna go over the nervous system. Okay, so we're gonna go over the central nervous system, the peripheral nervous system. We're gonna identify uh neurons, resting potential, action potential, and synaptic transmission. And then we gonna try figure out the physiological challenge and how does a biological cell convert chemical concentration gradients into ultra fast electrical signals to coordinate body-wide behavior. This is really interesting. Biology is something that you should pay attention to and don't do what I did. I need to be the good I know I'm gonna be a good example. So we're gonna the nervous system is primarily just split into two systems. The central nervous system, which includes the brain, spinal cord, and it acts like almost a command center. And then a peripheral nervous system, which is like all the neural tissue around the central nervous system. And this actually connects the center to the limbs and organs. And if you hear a lot of fidgeting, I don't know, I just can't stop. Just like I'm doing pencil spins. But like sometimes I drop it, but like I can't stop doing it because I don't know. Some people like do these infinities, and like I don't know how they do it. Just like, and there would be a chart showing divisions of the central and peripheral nervous system, but I think you can just imagine it because apparently, maybe this is testing your imagination. Okay, so we're gonna go over what a neuron is. So we have the dendrites right here, and these are branch extensions that receive signals from other neurons. And then we also have the cell body, or the soma, which contains the nucleus and organelles. Right here, right here, right here. And then we have the axon, which is the long fiber that transmits the impulse. And then we have the myelin sheath that protects the neuron, but also insulates layers and increases its speed. So we have three different functional classes. The first one is sensory, and this transmits information from the senses to the central nervous system for processing. And then the second one, oh shoot. The second one, we have interneurons, which are located within the central nervous system and is responsible for integration and local circuits. That was my brother, so every time like I stuttered, it's not me. It's not me, trust me. Okay, and then we have the motor, which carries out outward signals from the central nervous system to effector cells. Okay, don't ask what that was. That was like ASMR. That was ASMR. Maybe I'm letting my intrusive thoughts win. Okay, so we have the resting membrane potential. So we have so this is what we have. Just look at it. And the cytosol is negatively charged relative to the extracellular fluid, and this stored energy is the resting potential. Oh, we got the ion gradients, we got potassium, we got K plus, Na plus, we got proteins. Pretty interesting, yeah. Oh, look at this figure, bro. This is so good. How many subscribers I gain from this video is how much Jerry's gonna get on his paycheck. So if it's 0, he's not eating for a week. Okay, so the potential is maintained by active transport using the Na plus and potassium plus in the AT pass, and then this pumps out free Na plus for every 2K plus that goes in, and then this consumes ATP to counteract the leak of ions down their gradients, and this establishes the chemical driver for the action potential. And then we have all or none. Look at, make sure to pause the video anytime you see this cool graph and just like look at it. And if you do this, you'll understand everything. I don't know about everything, but everything. Trust me. I didn't look at. I don't know. I just dozed off. Okay, so an action potential is a massive change in membrane voltage that travels as a wave. The threshold is usually around negative 55 MV. Huh. And if the stimulus doesn't reach this, no impulse is ever fired. The strength of a signal is encoded by frequency and not its magnitude. So we have different phases. Oh, okay. We have different phases. Uh, so phase one is depolarization. Oh, make sure to pause. Look at this graph. Look at this graph. Look at it. Okay, so when the threshold is reached, the voltage gated Na plus channel swing open, and then the Na plus rushes into the cell down its concentration and electrical gradient. And then the membrane potential quickly climbs towards positive 40 MV. And this is what's called a positive feedback loop, where more Na plus leads to more channels opening. Second is repolarization, where at the peak, Na plus channel inactive. Oh no, at the peak, the Na plus channels are inactive, and the voltage gated K plus are open, and then this causes the K plus to rush out the cell and causes the potential to drop rapidly towards the negative. And this is when hyperpolarization happens, and this happens when the potential dips below 70, negative 70 briefly, and this is because the K plus channels are too slow to close. And this is what there's also something called a refractory period, where the time when a second action potential cannot be initiated because channels are resetting. And then the salutary conduction is in the axons and the myelinted axons as the signal jumps between the gaps in the sheath called node of Ranvier. This is significantly faster than continuous conduction because it minimizes the surface area that needs to be polarized. Make sure to look at this. Look at this. So good. Isn't this crazy? Speed up to 120 meters per second. I mean, that's pretty fast, but like I run a 2 second 40-yard dash. The NFL is like asking me if I wanted to like try out. I said nah. I just wanted to go over these videos, but what a career I chose. But okay, so now we're gonna go over the chemicals. Can we get a thumbs up in the chat for this graph? So good. So there's something called a chemical synapse, and this is when the impulse reaches the axon terminal and it triggers the release of neurotransmitters. And the calcium 2 plus enters the terminal, and the vesicles fuse with the presynaptic membranes, and the ligands cross the synaptic cleft, and then it binds to the receptors on the postsynaptic cells called an IPSP or EPSP. And if you're gonna ask me what those are, look at the graph, and if it's not there, moving on. So we have the most common neurotransmitters, acetylcholine, GABA, glutamate, and dopamine, and they all have like different effects, and they all have different functional roles, like memory, inhibitory, excitatory, or learning or reward circuit. But yeah, it's pretty cool. We're gonna go over. We're gonna go over a critical thinking challenge. You gotta use your noggin sometimes. So there's a scenario: the channel blockers. The tetrodotoxin found in pufferfish specifically blocks voltage-gated sodium channel. And if a neuron is exposed to this toxin, what would be the immediate effect on the action potential? So I'll let you figure that out. Yeah. So yeah, I'll give you a couple seconds. So while I scroll. Let's look at my emails. Do I got any cool emails? Of course not. Let's look at my stocks. Let's see how. Oh yeah. Oh yeah. Like typical. It's expected. Yeah, I expected this honestly. Yeah. Okay, so the solution you should have thought about is that neurons would be unable to depolarize, and then even if a stimulus reached the threshold, then no Na plus could enter the cell, which prevents the initiation and propagation of an impulse, and this leads to paralysis. That's scary. Okay, so there's a summary. Yeah, yeah. Summaries. Yeah, it's like a conclusion, where it's like not necessary, bro. But okay, so I'm gonna say the quote: "The brain is a world consisting of a number of unexplored continents and great stretches of unknown territory." S. Raymond. Y. Cajal. Yeah, my pronunciation is getting better. And here's a couple of the sources I used. And yeah, I hope you learned something today. I hope you know biology is pretty cool. And I hope you have a good day. Bye.